Hello everyone and welcome to Handmade Hero, show where we code a complete game live on stream. We are going to go use our parsing, our tag parsing that we've implemented to try to rebuild our entire HHT set with the exception of fonts, because we're going to take a look at those as a sort of separate thing. But we're going to rebuild everything but the font HHT set strictly from the tag files. That's what we'd like to get accomplished today. Maybe that's a little bit ambitious for today, but at least we want to get most of that accomplished today. And so that next weekend we can kind of look at wrapping that up and having kind of a nice art asset pipeline that we are happy with and think will be sufficient for not only shipping the game, but allowing people who are modifying the game or adding their own things to the game to have a reasonable time doing so, right? So, you know, making it so that we don't really have a lot of concerns about how that would work. So we've had one request today, and oops, you know what? I am not even my keyboard switcher was not even switched on to the correct let's get that. Oh, okay. Sorry about that. My keyboard switcher was still switched to the other machine, so I was about to start typing into the the machine that actually runs the stream, which would not have been good. Who knows what that would have done? All kinds of crazy stuff, perhaps, with as I was like trying to figure out why the keyboard isn't working. As I was trying to say, today is day 512, which of course, as you know, is a power of 2. We will possibly never have another power of 2 on Handmade Hero. I don't know. It's possible that we'll go to day 1024. But it's also possible, perhaps even likely, that we'll stop somewhere on, you know, day 800 or something will be the last stream when we sign off. I've said we're doing at least 600, so we know we're getting past there, but I never say anything about doing over 1,000, so we may stop before day 1024. And so in honor of the 512th stream, we had a request on the pre-stream that I use my announcer voice for at least part of the episode. I don't really use the announcer voice much anymore because I'm more comfortable just doing regular talking on Twitch. You know, when I first started doing the series, I did an announcer voice for folks. And I guess some people miss it, which is totally fair. And I think that's a totally reasonable request, so without further ado, I will start doing announcer style for this day 512. I can't remember who asked for it. I've read the sequel, asked for it. I've read the sequel. This one is for you. I wish I had some almond milk. Sorry, I don't have any. Okay, ladies and gentlemen, we are here at Handmade Hero, as was the case with the very first time that we did programming on Handmade Hero. I am doing my announcer voice by request for day 512. Really excited today because today we are going to be looking at the parsing code and seeing if we can actually get it to generate some HHAs. Now, it's not a given. There's a lot of things that can go wrong here. We've tested the parser so that we know the parser works pretty darn well, but here's the thing. It's reading into sort of the asset system, which, as we know, just deals with packed assets. Anytime you're trying to go directly into a runtime format like that, it's a little bit dicey. It's one of the reasons that people often don't try to pull off something like this. They typically use more intermediate object formats, stuff like that, where they kind of move things through the pipeline a little bit more slowly than this. But that's okay. This is Handmade Hero. We're good for it. We can go ahead and try. So I am not concerned about it. I just think you might expect it to take a little bit longer as we kind of work our way through it. Now I'm going to pop open the Handmade Hero project here so all the files are loaded. We're going to first jump into that asset system. As I said, we did a lot of the work already, so we're kind of in good shape here. Everything's in a reasonable setup. So, you know, we've left ourselves a good chance of success. Remember, we've got this parse HHT here, and what we're doing right now is we're calling that with a couple different things. First of all, we're giving you the game asset structure. And remember, this thing allows us to get at absolutely everything that's stored in the asset system at any given time as far as the game knows. So it's loaded the HHAs, it knows about all of the source files that we've actually used so far, because it's actually created sort of a backing, like a backing network, if you will, that tells where absolutely everything is. So that's the key for us differentiating anything that comes in anew, it's a key for us to be able to look up and say, do we already know about this thing? Do we have this thing stored already in an HHA? If so, we can just update it. If not, then we're going to have to add a new thing for it and so on. So that's where all the tags go. That's where all the sort of higher level information goes after we kind of get it into the system. Now we've also got this import source info. Import source info, very important structure, tells us about where it's coming from now, right? That import source info tells us things. Now, what you can kind of see here is that the flow is a little bit broken. Why is the flow a little bit broken? Remember, the way we were doing this before is we were iterating over PNG files first, okay? We were saying, look, operating system, tell me where all the PNGs are. I'm gonna look at each PNG in series, okay? Take that, say, what's the source info for that PNG, right? What's the name of it? What's the last write modification time? Okay, that's the information we had for a PNG. We were looking for it. We then know that PNG maps to a game asset, okay? One of those game assets that we've already processed, it maps to it. Or it doesn't if we haven't seen it yet, but if we have seen it before, it maps to one of those things. So that source info represents a particular PNG backing file. Now, what's the problem here? Can you see it? Hopefully you can. Before what we were doing with the import changed assets, we're looping over the PNGs. We have the source info coming into the stage where we're looking at things for the first time. That's where that source info is coming from. We're not going to have that here at parse HHT this time. So it's a little premature for us to flow that down the pipeline like this. Import source info is actually going to happen in the next stage, right? Why? Because the HHT is just one big text file, and it's got a number of blocks, each of which refer to one of those specific PNG files. So every single block we parse, we're going to have to be generating a new source info. Don't believe me? Well, let's take a look. If I go over here to import source info like so, what you can see is it's got a name, a description, and an author. The name is the thing that's going to name this particular asset. The description is the thing that tells us about the asset we want, and the author is the thing that said who made it. Now, we don't know that stuff till we've parsed the block, right? So that's where this big change is coming from. So again, we did this. I'm not upset that we did this. It's totally fine. We were just trying to piece together the process from before. We were locking the two things in together to make sure that they flowed all right. So we weren't thinking about it at that time, and we weren't supposed to be thinking about it at that time. But now that we're going to get it working correctly, we need to start thinking about how that flow goes. So the first thing we're going to do is we're going to move that import source info. We're going to move it over here to parse top level block because that's where it's going to go. Okay, so we know that that's going to come in here somewhere. All right. So we don't actually want this HHT context to actually have this in it anymore because that HHT context is really the thing that flows from top level block to top level block. And so that's kind of coming in here. Now what you can also see is, hey, look at this. It's basically this struct. So really we already had this concept from before. We just remade it. It was just kind of a slight mistake that we made there where we're thinking like, whoops, right? So we don't really want that. We don't really want that at all. So this import source info is actually something that we can generate almost entirely to pass down. We don't really have to track it at all. So when we actually come in here to parse pieces, right? If into parse pieces we were actually going to have to pass that source info, we would just generate it right here because we have the actual information. Now there's something to remind yourself of here. You can notice we had that there was that name field there. Why was there a name field there? Well, it turns out you can name each individual one of these assets. I don't know that we really want to do that, but we have the ability to do it. Why do we have the ability to do it? Well, if we look at the source file format, right? So here's the file format for Handmade Hero. What we decided to do is have these annotations. The annotations can be stripped. We probably won't strip them, but we designed it to be stripped as sort of a nod towards professional programming, where we're saying like, look, you'd probably want to strip these if you were actually shipping this as an unmoddable game. This game will be shipped in a way that allows people to mod it, obviously, because hey, the whole point of Handmade Hero is that you learn to program. So we're probably not going to strip these annotations, but we want to be able to say you could strip them if you wanted to. So if you wanted to run the game without any of the cruft that's sitting there that's giving you this markup, you could strip these annotations. But if you look at what's in the annotations themselves, you can see we've got the source file date, source file checksum, the base name offset, the asset name, the asset description, the author, the error stream, right? Sorry, I said base name offset. I actually meant base name, right? All assets in there. Asset name, that's the one, right, that we don't fill out currently. Nobody fills that out. We don't have a name for the asset, right? So what we want to do here is say, well, wait, now we could, if we wanted to, we might as well support the features that we actually created. So if we go into that HHT, which I guess I haven't loaded yet, so I don't know why I thought I could bring it up, but here we go. It's right here, right? If we went into this HHT, what I could do is say, oh, all right, so if I wanted to name one of these things, I could. I could in here say that I've got a name for this, you know, this this block, whatever it is, block forest 01, I could just call this like, you know, forest terrain or something if I wanted to. Now, again, I don't actually know that we care about this. We don't know, but we've got the ability to do it, so we might as well support it in the parser and just see what happens, because it's basically free for us to do so. If you look at what's happening here, the author, the description, these things are just meaningless fields that we parse. They take almost no effort to do. We can simplify it even further than we've simplified it here if we want to, by just having a concept of a set of named fields based on an enum. We don't even need to do that right now. It's not necessary, so I'm not going to bother doing that. But if you look, I can just sort of do it here as a way of saying, look, let's just get the name into our fields as we were doing everything else, and then we now support that, right? So now we've magically got that working. So now the HHT fields that we've got there, we can support them all. We can support all the things that were actually in that part of the file format exactly as they were. So that's great, that's all done, and now we know what that source info is. We've looked at it, we can generate that at any time, so if someone actually wants that source info, we're good to go. Where would we use that source info? Well, now let's start to peel that apart, right? Because let's look at where that was actually going on. Drop down in here into port out assets. Here's where parse pieces was getting called, right? Right here, you can see how parse pieces was getting called. We're still gonna be calling parse pieces. Remember, we did the work to generate that tag stuff. We still got a little more work to do because we have to package those tags into an append array. We want to have a way of appending those tags that we read inside the text file, right? These tags over here, right? We need to append those to everything in addition to the ones that we automatically fill in on the grid for the user as part of that knowledge of what is a block, what is a character. We know certain tags apply to every single grid, right? Each individual grid cell in one of those files has a specific set of tags that always go with it. But then there's the additional tags that come from the actual HHT markup file. Those have to get combined, right? So what we want to do is parse that tag array into a tag block. Then the other tags that are coming from the automatically understood ones from the cell layout, those are sort of getting merged together each time we do it. And we could probably clean up the way that's happening. Right now, you know, it's a little bit janky the way it's doing it. We just try to keep the code that we have. We could try to tease that out a little bit more. There's a bunch of things that we could do if we really wanted to that we would be able to sort of like make that a little bit more of a programmable or richer system. We can consider that a little later on. Right now, I don't want to put too many things in the mix at once. I just want to do it as close as possible to the original way that we were going to do it, right? So that's fine. Anyway, when we go back here to the parse pieces set, the parse pieces set is going to give us back the import type, and the import type is going to get acted on here. If you look at how that import type is being acted on, what you can see is that in there, the source info is actually getting pushed down because multi-tile import, single-tile import, and plate import all generate actual assets in the backing asset store, in the HHA, right? When it generates those HHA assets, that's when it needs those strings. So that's the time that we need to provide this info structure. And so if you look at how that was happening up here, right, we can just mirror this process almost exactly the way that we were going to do it before. So let's go ahead and do that. Let's just pull this code out because it's exactly the code that we need. Let's just pull this code out and work with it. So I'm going to grab it here. I'm going to pull it up to this parse top level block that we've got. When we come through here, after we're done parsing, assuming that we had a valid parse, right? Because I can, if I want to, I can couch this. I can say, look, as I went through here, I did a bunch of parsing. I can always do a really simple check. Remember, we designed that parser pretty nice. It was not only parse, the tokenizer. We designed that tokenizer nicely so that it just remembers if it's ever had an error. So when we're doing parsing, we can just say, look, if there was ever an error, we don't want to do this. So we just wrap it in an if parsing block, and off we go, right? So that's really a pretty simple way to make sure that we don't get into here. I'm going to move it over here so it's outside of the way of my head. Right? That's a pretty simple way to make sure that we're not going to have any problems processing art data when we actually got some kind of a bogus block in the file, right? So we'll just only keep it to syntactically correct blocks. That's the only kind that we're going to process. We won't look at anything else. We'll stop the processing there and say, look, you got a problem in your HTTP file, fix it, and then we'll talk, right? So parse pieces really wants to go down here, and this is why I was saying before, this found equals true or found equals false, and so on. we kind of want to change a little bit about the way that's working. I think that import type is really the, sort of something that wants to happen a little later on and so on. So we really want to do, I think, is we want to say when we set up the default situation here, that's more what we're looking for. So when we come through here, we want to pull out this part where we grab, and you can sort of see there's one part we have an issue, this require token part, we do the token string. We still need that part here to occur, only in the case where it's not the default, right? So we still want to be able to do it this way, where we say, look, is it the default block? If the default block doesn't have a name, if it does have a name, or if it's not the default block, it does have a name, so make sure we get that. And get that file name out of there, but either way, we just need to know which one it is. And so the found part of things is going to change. I'm going to change this to is default, and I'm going to say that the is default is true. It's false. I'm going to say that is default gets set to true on the case where the token equals the default. Otherwise, what I'm going to do down here is say, all right, we'll get the file name, and we'll leave is default to false, right? So hopefully that makes sense for everybody. Okay. So now, as we go, what we want to do down here is say, look, if, pretty much period, we want to parse everything, but if it's the default block, we don't want to process any art assets, right? Like, we don't want to do anything with art assets if we don't, if we are saying that we're just going to set the default settings for any given block, we don't want to, like, read PNGs or, like, create the tag, the matrix for the tag, grid and all that sort of stuff, right? We don't want to do that ever if we're actually just parsing the default block. We just want to get the defaults in and be done with it. So we want to make sure that we do that check later. So I'm going to go ahead and grab this part here. We're going to move it down, and then we're going to get rid of that found, right? This found thing is not what we want. We want an if default, and we want that to happen down here. So what we want to do is say, all right, in the case that we have a default, then we're going to set that if up down here to deal with that, right? So if it is not the default, then off we go. So all of this stuff here, right, this all just works fine. Now, what I could do, and this now gives us the opportunity to make this maybe even a little more clean than it was before, we've got those fields, right? We've got these fields here, these HHT fields. What I could do is say, look, let's take those fields and let's think about a little bit how we want those to work. If I just said from now on, we've got HHT fields, and that's going to start out with nothing in it, right? We've got no fields in there. We look and see if it's the default, we're going to do this, and if it wasn't, we're going to do this. What if we just said, nah, let's not do that. Let's just say is default is directly defined by this, right? So, meaning we just set is default right away, right? And then the only thing that we actually need to do here is we just need to say, well, if it's not the default, then we need to read in that file name. But otherwise, we don't have to, right? Then this whole thing can just operate on the fields array that we've got, right? So I can replace all of those that were previously using the arrow syntax, the dot syntax. We're just putting it into our local, the one on the stack, right? And then what I could do is say, at the end, once we've parsed all of the stuff, like everything that there is, right? At the end, if it's the default, then we'll write the default. Otherwise, we'll merge in the default, right? And similarly up here, we could do that part as well if we want to. I don't really know. In other words, we could do it this way, where we're saying, look, if it's the default, well, actually, I guess it's just this part, to be honest, right? We would just say, look, if it's the default, then we don't have to do anything. If it is other than the default, then we write our fields from the ones that are in the context, right? So that's like, if it's the default, we go just by reading in a new set of defaults, and presumably we don't want to keep the defaults from before because maybe you were trying to remove some defaults or something. I'm not sure. We could choose to merge defaults. I'm not sure which one we want to do. The only difference would be we would put this line up here, and I just don't know which of those we want to do. I suppose you can always clear defaults by just putting in a quote unquote. So maybe you want to just have them. You know what? Let's just say that we always cascade defaults. So that would just look like this, right? So the fields always gets initialized to the defaults, and then even if you're reading defaults, then all we do is just like overwrite ones that you change, but we keep any ones that you didn't talk about. So that just parses straight through, and then at the end we say, look, if it's the default, we'll write back the default, right? So we'll say the default fields come from whichever fields we just processed. Otherwise, we just process this as a normal art asset, right? So now you can see that got a little cleaner. This is now straight line code. You don't have to read any ifing around it or any of that stuff. Literally the only thing we do is say, well, if it's the default, it doesn't have a name because we just don't put one there. So we don't require you to have that name string that we would otherwise require you to have. That's the only difference, right, between them. So all this stuff flows properly now, I think. Looks nice to me. We've got the default handling or not as appropriate in here. We can also say that we won't set the default. We can if this entire thing if we want to, so it looks a little bit more like that. And that way we just say, look, don't enter this block unless things went properly. Now, the other thing we can do here is go and do this part a little bit differently as well. So we'll do it like that. So now what we could do is make our parse pieces call actually get all the data that it actually needed because we've already parsed everything. And the only big if is this guy right here. We haven't done him yet. But that's okay because actually he's going to be pretty simple. We're just going to use the tag builder we already have and then parse the array that comes back from it. Or I should say pass the array that comes back to it over to parse pieces as the append tag type. It's going to be easy. You'll see. Trust me on this one, it's going to be easy. All right, so anyway, we come down through here. This import tag array that we do for append, that's the thing that we know we're going to have to deal with that in a little bit, right? So that append tag array is going to have to be up here. And it's going to have to get filled out by this parse tag list. So I mean, I might as well just do that and say, hey, give us back the tag array. I guess I could do another way and say, look, return that to us. There we go. And maybe I'll call that append tags, just to make it a little bit clearer what that is in case someone's reading through the code. Just the word append is like what's going on there. So we got append tags. We're going to grab those tags out. Those append tags are going to get added on here, right? And then we've got those import grid tags right here. So this whole thing where we do parse pieces, that should actually work because I think we ported it all yesterday, and it should be pretty good, actually. So I think we're actually fairly good to go there. Then what's going to happen is when we're done with that, what we're going to do is we're going to get back whichever the import type is. You can see how we're doing this here. This is old news. We don't really need that anymore because we got this right up here. Here's the code that allows us to actually do the import, and then here is the part where we error out on the case where we don't actually know what the block type is, so we just need that block token to get passed in here. And remember, the block token was passed into us, right? And so we, kind of know there what's going on. All right. So once we have all of that working and we do that parse pieces and all that stuff and everything's fine and dandy, this is the only part that we now have to parse. Remember, we've got some busy work to do here. We need to know like sort of stuff about where we're going to put the memory and all that sort of stuff. We have all that worked out. It's not really a big deal, but we need to kind of merge these things together. And so if you look here, we've got the error stream. You can see where we've got the error buffer going here. And what we wanted to do in each of these cases is we want the error stream to go with the file in question. So anytime we get errors, we want to vector them towards the file in question. Now, in order to do that, we want to start making it so that we're looking at which file is talked about by the block. So if the block says block 01 blah, 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 or whatever, .png, we want to put all of the errors so that they are on that PNG. So that anyone who's looking at that PNG or wants to ask about, was this PNG work okay? It'll be like, no, it didn't, if there was an error in there. So we've got those recorded with the actual art asset as well as whatever the actual import process is. So we kind of want that to be a little bit clearer. So let's see how we start to make this stuff all flow together. First of all, this needs the temp arena. That's totally fine because we can add that in here. So we've got the temp arena put in the context, no problem. So anyone who wanted to use the temp arena here can just do that. Although, you know what, now that I look at it, it looks like it only wants it local. It doesn't really even need it for anything else. So to be honest with you, I guess we don't even need that. It can just do it here. So that's all fine. So that just looks like it's totally fine. It'll handle itself, no issues. So really, I guess what we need is here, we need the file group that we're opening the file with. And then we've got some more information here that we've got to fill in, like that file info structure. Remember, we added support to the platform layer yesterday to be able to give us file infos by name. So we should be able to use that here to construct a name that we can then get a file info from. So that's going to be the main thing. Other than that, this all looks like it flows. You can see it getting the file buffer size here. It's going to read the data in. And it's going to close it. It's going to look at the matching. And see whether or not the thing changed since the last time it read it. And if it did or didn't, it's going to have to do some time parameters. Now, there's an interesting thing about this that we're going to have to consider that's a little bit squinky here, right? And this part's going to be hard. we don't know whether or not the user has changed the data in the HHT that corresponds to this file, right? We're looking at the PNG, we can see whether or not you've touched the PNG because the date on the PNG will tell us whether or not it's the same as the one that we read in last time. If the two dates are different, then we have reason to believe that they've changed, right? So that's pretty simple. We don't have to do a lot of work there to know whether we should reprocess the file. Really clean and simple, not a lot of problems there. Now there are, you could say, well, the date isn't completely dispositive. Maybe the date stayed the same or who knows what, right? We don't really care about crazy edge cases like this because the person can always retouch the file if they, for some reason it's not re-importing for them if some weird edge case occurs. So we don't really care too much about that. But we know that the file date will give us that information pretty much any time that there's been a substantive change to the thing. If someone repaints anything in it and resaves it, it's going to have a different file date on it on that machine, and so it will force a re-importation. And so that works totally fine. What doesn't work totally fine is the fact that when we look in here and we see that the HHT file has these tags or the name or the description or anything else in there, we don't know whether that has changed. So that information that's in the HHT file that says what should happen, that could have changed. And the only way we can really know whether that has changed or not is to actually do some kind of a diff on the data, right? We're going to have some kind of checksumming that says, is this actual data different? Because if the data's different, then we're going to have to do something about it. And if the data's not different, then we only have to do something about it if the underlying file's date has changed, or the checksum. We also do checksumming in here as sort of a backup to the file date, right? That's trickier. So if we go over to the shared side of things, we actually have a murmur hash that was thrown in here, right? This thing right here. And we have the ability to do sort of this murmur hash update. And so if we want to murmur hash something, you can see we call this checksum of, and we can give it a buffer, right? And we can also just feed it one thing at a time, right? So you can see here, we can just call murmur hash update as many times as we want to, and then call murmur hash finalize and be done with it, right? So if we wanted to, we could actually in here have a thing that checksums the actual data that we're going to store prior to doing anything else, right? And so what we could do is say, let's start checksumming that in addition to the rest of the stuff that we're checksumming so that we can know whether or not this thing changed, right? So we can know whether or not the PNG changed or not. Now, if you look at what happens in here, we can start getting now into the part that's going to be a little bit squinkier, right? This part is the part that's going to be tough, okay? So if you look at what happens here, we generate the string hash, we get the backing file, and then we see whether the dates have changed. If the dates have changed, then we start processing the thing. We need to duplicate this logic, certainly, so that we can do the same sort of backing and store testing that we've done before. The problem is, like I said, we don't know whether the HHT changed, and I don't know where we're going to store that information. I guess we have to put some checksumming into the annotations for the HHA file. I'm not sure what else we could do. I think we're going to have to do that because we don't really have any other way. Now, we left ourselves space to throw it in there. Seems like we're probably going to have to. If you take a look at what we've actually got here in terms of checksumming, I'm not sure where we were putting that information. It looks like source file checksum is what we store there, right? So you can kind of see that we're keeping that information. And so the source file checksum probably has to be augmented to be like HHT block checksum, and that block of data that actually tells us what, that actually describes the file, that's going to have to be checksummed. I don't see any other way around it. Do you? I don't. So I'm going to go ahead and add it in there. So I think in our HHT annotation, we're going to have a thing called like HHT block checksum, like so, and that'll use one of our U64s that we didn't have in there. What we're going to have to do is build that oops, I spelled it wrong. We're going to have to build that checksum in there. And furthermore, in here where we've got the loaded HHA annotation, we don't actually, I don't really know where that's actually getting used. I'm going to take a quick look actually to see where that's getting used because I don't know. So if I do a quick check, for where that's actually getting used. It's only getting used in the HHT edit at the moment, it looks like. So basically what's happening in there is when you load those in, they go in here. And I guess they're probably being used for like transferring things back and forth. That is important. So let's go ahead and put that in here. So this is the HHT block checksum. I'm just going to call it that. And then what I'm going to do is I'm going to go in there and look at any place that we were previously using those annotations. I want to make sure that we capture both of those. And so here, I'm going to go over here so my head's not in the way. If we look at those checksums that we've got here, you can see them getting printed out here. All I want to do is just augment this so that we have the HHT block checksum in both cases, right? And that allows us to copy these around and do all the stuff that we were doing before with our HHT files without having to really worry about it, right? So we know that now the HHT block checksum will get kind of convected around in that way. So that seems fine to me. Again, I don't see any other way to do it. If I saw a simpler way to make sure we were keeping up to date, I would, but I just don't know any other way to do it. I can't think of anything that would help there. So when we're printing this out, like again, this sort of from situation, I will also add the HHT printout in here so that we have an HHT checksum. So here I'm going to put that in as a size T, and I'm going to put HHT block checksum, and we'll just call that done for now, and then we just actually have to use it. So I'm going to go ahead and build, right, and get that going, and then I'm going to go jump back to what we were doing before. Okay, so append tags we haven't done yet, and all this sort of stuff we're going to have to start making all this stuff work clean and make sure that everything's fine. Okay, so two sets of things. There's that source file checksum. I don't even know if we're really using that right now. I don't think we actually do an out if the checksums match. I think we leave it sort of the way it is. But what we want to do here is kind of move forward a little bit on that. Now there's a couple things. There's a little bit of minutia there that I want to talk about real first. Just a tiny little bit. So if you go back to what's happening with the checksums and the file dates. File dates are great for letting the system know whether or not it should process a particular file or look at that file for changes, right? Now there is a thing that we probably did, and I don't know, maybe we did it wrong. I'll kind of explain to you what the problem is, and then you can sort of think about whether we did it wrong or we did it right. It's hard to say. So inside the HHT annotation, you can see that we store the source file date, right? That source file date is actually stored in the HHT file itself, and it says, hey, this is the date of the PNG or whatever that this thing came from, right? That's the date. Now there's an issue. So if I go here, oops, I want to show you what I'm talking about. Just to give you a full illustration. So let's suppose that let's take the Handmade Hero site, okay? If I inspect this bitmap here or whatever, right? I'm gonna get an actual PNG. You know, here's the PNG. It's stored on the web somewhere, right? Now, that PNG wasn't made today. That PNG was made a long time ago when I made this website, right? But if I were to save this image, so, you know, let's say I go here and grab this out, right? There's the path to the actual image. So I stick that on here and I say, well, you know what? Let's take a look at the image. There it is, right? I hit Save Image As, and I'll just save it to the desktop as exactly what the name of the thing is. And I'm going to open it. Here it is. So now this is local on my machine. Same image, exactly the same, right? The problem is, if I then go to the desktop here and I look at the properties of this image, what you can see is that the date, right, the last modification time is today. Why do I bring this up? The problem is when people download these things from the internet, the PNGs for Handmade here or anything else, it's gonna have the date they downloaded it. So all of those dates are not gonna match the first time they download. That gives us the following problem, and I don't know if it's a problem, but I'm just trying to give you what it is. I have an HHT file. The HHT file I got with my distribution of Handmade Hero. Inside the HHT file is the checksum and the date of the source file that was used to create it. So far, so good. Problem is, if I download all the sets of PNGs and I say, hey, do you need to rebuild anything? It's going to go look and say all of these dates mismatch. Now, we've got a checksum, so it's not a huge deal. It's going to look at the checksum and say, oh, you know what? The checksums actually match. So it turns out the date was the date in the file got changed, but it didn't actually update. I don't have to update this HHA. Great news. Problem is, where's it going to put that information so it doesn't have to check it next time? It's got to set that source file date so that the source file date now matches the one that got written on the drive. That means that the HHA file has to get edited even though no edits occurred. You with me so far? So in some sense, what we really want to do here is we want the source file date to be stored out of band from the HHA, because really all it is a machine-specific optimization file that says on this machine, have I or haven't I had to update this file yet, and what was the date when I did? Okay? So I think we made kind of a mistake there, because file dates are not preserved across copies. Now, they are preserved as some copies, right? When you actually copy on the machine, sometimes that actually does preserve it. So it's not entirely true to say that it's never preserved, but it's most of the time not preserved. And most importantly, it's not preserved in the one case we actually care about, which is if somebody downloaded these pings from the internet, they may very well not be a thing. I don't remember what happens if you take a zip file and you zip up a bunch of PNGs and unzip it. I don't know whether they get the dates from when they were zipped in or whether they get the dates for when they were zipped out. I'm not sure I remember which one it is. But point being, there are plenty of cases, as I just demonstrated to you, where you could go get PNGs that are the exact same PNGs that were used to build the HHT file, but they would all have different dates. The only thing that remained the same is the checksum. So that's something that we really want to be aware of, and we kind of need to figure out some way of having that be remembered in a way that doesn't require updating the HHA file. So we kind of need a local cache file that gets written there when it's actually doing that kind of mashup. I don't know any other way to do that other than creating sort of like a separate file that's sort of like a backing store, right? And that backing store will give us that information. That's all I can think of. I don't have any better ideas than that. Just a local cache file that writes that information out. Now, since we already have the concept that we're going to have save games and stuff like that, it seems fine to have that as a separate file in there. So there's kind of like a save package. And that save package just to have like, oh, here's all the things in it that we're actually using, right? To run on this machine, specifically this machine, and we can have those packaged in there, what those source file dates are. That seems like an okay trade-off, I guess, maybe, I don't know, possibly, but we, you know, I'm not sure, again, if that's maybe a bridge too far. Are we being too professional almost at this point? You know, is that something that should concern us or is it not? So that's the part that I want to raise your awareness of. So for now, we're going to use that, but I'm going to put a big old to-do in here and say to-do, should we start storing source file date out of band so that we don't have to update HHAs when dates change, but checksums don't, right? So that's just some way of saying, hey, look, we're probably going to have to address this and maybe remove this, and this will be a dead field as empty. We can still fill it out. We can still fill it out and say this is when the HHA, when you received it, when you received the packaged version. And so anytime we actually update the actual data in here, we will set it so you kind of know what the date was. That's not a bad idea. Should say it that way, right? But we need that other one so that we don't keep rechecking the files. I'm just going to mark that. I think we should probably do it. I'm not going to do it right now, but that's something to be aware of. All right, let's move the rest of this stuff over. Let's grab all this stuff out. And we've got the sort of file group part here. This is actually going to also move out, but it's going to probably be something that happens around the parse HHT itself, which is sort of the file group backing store stuff. So I'm going to go ahead and grab that here. I'm going to go ahead and grab the one down here as well. And again, these are just sort of another thing that we're going to have to work with there. All right. Okay. Actually, you know what? I lied. That's not true. I think those are actually going to stay exactly where they are because we're going to do that for HHTs. Okay. So what we're going to do here is we're going to say, all right, for each of these HHTs, we're going to want to iterate over all the HHTs in it. We're going to want to load each of them, right? So here's us doing that. And in here, we don't actually care about this anymore. What we're going to do, what was that to do? do a sweep mark also has to be unseen, then mark each one we see so we can check if it's deleted. That we don't have to do anymore because actually the HHT lets us know. Although, well, inside the HHA we don't really do that. So yeah, maybe I'll leave that to do. I don't know that we ever actually want to do that because you can just delete the HHA and rebuild it from scratch if you want to get rid of anything that was in there. So maybe not. But anyway, so here we go. This is going to let us loop over each of those HHT files that are currently being stored in the drive. So we'll get that data out. We'll process each one of them. This part right here, we still probably want to do. We're using the asset source match here as sort of a separate thing. That means that this sort of thing where we do the string hashing is going to be something that we actually do multiple times. And so we kind of want that string hash to be something that we can call more easily. So this particular thing, yeah, like I don't, also, why did we write it this way? Is there a reason we didn't write that? And is there also a reason that we didn't put the, like, what happened here? Is there a reason that didn't look like that? Does anyone know? I don't know. Well, we got a pretty tortured thing there. All right, I don't know what was going on there. So when we're actually doing that, we got the scan here. It looks like we were probably, my guess is we were doing something with the file name inside there in addition to what it was before. So, you know, maybe this was previously, I think maybe a little bit more elaborate. And so then it kind of came to something else. What we should probably do is just use a hash of. I think we have a hash of that actually takes a string as it is, right? There's a string hash of right there. So we really don't need to do any of this. We got the hash value. So we should actually be able to just do that, right? I would think. And then just say, give us what the hash of the base name is. All of this can just go away, right? I mean, I think we were just maybe being a little bit overly squinky there. We didn't really need to do that. So I don't know. And the anchor part, yeah, again, so I think that's all residual, right? I think that was all there because we were parsing the file names before and we were doing other stuff. That's done now. So that was like old vestigial remains. We removed stuff. We didn't really realize we removed it. All that stuff can go away now. We don't need the anchor part or any of that stuff. We can just hash the base name directly and be done with it. We don't even really need to store the hash value because that actually happens here. So what we can do, you know, I mean, keep it there, but we could just actually even inline it right here. So all that would be fine. So there we go. Get or create as source file name. We got the hash file there, value there. This file, this could now generate that hash value if we want to. Probably should because there's really no reason for it not to. So let's just jump back up there to get or create asset source file name. Sorry, get or create asset source file. Looking at that, we've got file data checksum, blah, 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 blah. There's the unmodded hash value. So yeah, like we don't really need to do that anymore. The unmodded hash value, who's actually calling this? I mean, and does anyone actually care? Because what we could just do is pass just the base name from now on. Excuse me. And yeah, you can see that we just, I don't think we need that. I don't think we need that on there because you can see it's already got the one that just takes the base. Yeah, so really, I don't even know why we have that separate call. That was just kind of dumb. It's not really even necessary. I could break that out into two now. So let's just forget this whole thing. Just pretend it never happened. We're just going to say that it was, you know, forget it. And then down in here, we do a get or create asset source file. What I'm going to do there is I'm going to go ahead and grab this version of the call and call that instead so that we just pass the base name down there. We've got the file date and the file checksum that actually get passed there. I don't know which version of this we were calling before or why those weren't getting passed. I guess because in here we were just calling this one. And so the file date stuff, you can see it doing some modifications there on those. Yeah, now I think about it, I guess I can't really do that because that is one that automatically always updates the checksum, and the file date, we don't have the checksum to pass it yet because we haven't actually done that. So I do have to pass the unmodded hash value here, but I think, again, not really necessary because what I can do is just change the way this is working to say, look, just pass me that base name so that we can keep doing it exactly like this. Then when no one has to know about the fact that it's getting hashed one way or the other, in here we'll just go ahead and delete this, and then what we do is create unmodded hash value ourselves. We just say right in here, grab that base name hash right at the time, right? So that just cleans all of that up, and now we're done with that. So I think that's the way we want to do that going forwards. And that way we can get or create the asset source file out of here. We can look at the match dates. This is the HHT. Remember, it's not a PNG. It's not any source file that's actually going to create an asset. It's just the thing that creates the tag set, right? It's the thing that like does all the markup for them. So we grab that. If we get a match, then we know we want to parse this thing. We're going to call the HHT parser right here. We're going to call it with all the info that we have. So I'm going to go ahead and set this up. This is no longer to do. We actually now have the ability to mark that up thanks to the HHT file. So thankfully that is all just fine. No issues there. We've got the tokenizer we need to set up. The game assets are already set up for us. We don't have to worry about those at all. We got this import situation going on here. Again, I'm going to just copy this code up here in case we need to look at it for some other reason. I don't think we're going to because we're already calling parts pieces. If we look at it, okay, we've already got that. And this part right here, I don't know if we'll have to look at. So I'm just going to comment that up there until we go up and look on that code. We'll take a look. But for right now, we don't care. So here we're going to come in here, looking at all the HTTP files, parse each one in turn. Only thing we haven't done, create that tokenizer. Source info, not necessary. It doesn't get parsed. It gets created a little bit earlier, a little bit later down the line. So we don't need to worry about that. What we do need to worry about is the fact that here, we do want to be passing that file group. Because remember, the file group is what keeps all those infos, manages all those infos and those weird UTF strings and all that crap. So we're going to kind of need that as we're doing our file pulling later on. So we are going to want to pass that down in addition to the tokenizer. So that's something that's going to get passed down through. It's probably also going to be added to the context here. So right here where we pass that file group down, it's probably going to get added in here. So I'm just going to go ahead and do that just ahead of time because I know I'm going to need it. The HHT context itself, again, hasn't been pulled out yet. It's right in here. I'm going to go ahead and pull it out so we can see it a little bit easier. Put it in the H file just so it's clear what's going on. So I'm going to put it out here. And that means in here we've got that file group. Oh, sorry, it's platform file group, right? Platform file group, like so. And that's going to get added on there, right? Again, we're going to use that a little bit later, you'll see, because we need to get that file info back. So we have that whole set of stuff that's got to happen, and we'll deal with that in a second. So in import asset changes, now looking pretty good. Import changed assets, rather, is looking pretty good. We're looping over each of the individual file shows, getting the asset source file for each of them based off of that name that's coming back from the file info iteration. And anytime we see one that doesn't match as file date wise, we go ahead and parse it, right? We go ahead and pull things in there. Now, we have a problem here. And I guess what I would say is, excuse me, we need this to run in two different ways. And I'm not sure exactly which way we want it to run. I'm going to start by doing it one way, and then we might change to do it the other way. If we did it this way, what would happen is you'd have to touch an HHT file in order to get anything to reload. Why? Because the HHT files are the only things that are getting iterated over at the top level, right? They're the things that tell us what all the other stuff we should look for is. So if you were to update a PNG and save it, we would not know that we need to reload because the HHT hasn't changed. So we never even look at the PNG, right? So what I'm going to do first is I'm going to say, let's always, when we do import changes, parse the HHTs, and then is a second step, we will look at this part for each of our file matches, okay? So that information would go down in here, and so every time we do that parse pieces call, in fact, we would do it right here. Every time we're going to do that parsing call, we'll do this, right? And so we're doing that checking every time. We're going to do the file date checking every time on every PNG. We're going to do the full parse each time. Now, the question is, do we need to early out the HHT testing? If we do need to do early out the HHT testing, then we will have to put in something here which does that date checking differently so that we never load the files. I'm just going to guess that HHT files are never going to be big enough that we ever have to do it. And so I'm just going to put a note here that says, at the moment, we can afford to parse the HHTs every time, so we don't try to do separated file date checking. Right? So we're just not going to do that right now, and it's going to be fine. Okay? And so we do need to do the sweep of the unseen asset stuff here. That's still a to-do that we might want to concern ourselves with, but that bottom part won't necessarily be. So we're going to come through here. Every time we'll reparse the whole HHT. So every time you say reload, we'll reparse the HHT files. And then what we need to do in here is just say, look, anytime we get a particular file that the HHT references, that's when we're now going to have to do this part, right? So the question is, where does base name come from? Well, base name comes almost, not quite, almost. It almost comes from whatever the string is that we pulled out of file name. So this right here tells us the text sort of, right? Now, why do I say sort of? because it hasn't actually had the rest of its path appended, okay? So what we need to do is we need to rebuild here a bigger file name, right? A file name that's more explicit. What do I mean by that? Well, let's take a look at our directory structure. If I jump into Handmade here, I look at our directory structure, you can see in here we've got a whole bunch of things going on. We know that inside our sources directory, we've got sources, and then we got like base game, intro, cutscene, right? Inside base game, we got the art, music directory, blah, 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 right? We need this stuff to be appended. We don't have any of that in there. The base name is just like block.png or something, right? It doesn't know where it comes from. So we have to build a file name that actually will reach into the correct location. We know that Handmade Hero gets run in the Handmade directory. That's a requirement. That's how it knows where all of its files are going to come from. But it needs to be able to search down that source tree all the way as far as it needs to go, right? That's pretty important. So what we need to do is we need to have our HHA file stuff so that that all works and all the stuff gets found correctly. So I want the HHA here to be maybe specified that way. I'm going to say the intro cutscene, and that one should specify that way. You can see it's not actually getting one in there. I'm going to go ahead in here and put that in here. Oh, look at this. Look at this, though. Look at this. We're using it. We're using it already. Look at this. Check it out. We can actually label the authors properly really easily. Pretty nice, huh? Yeah, you didn't think it was cool. It's cool, right? Because Anna made this and Yangshin made these, right? I rest my case. Anyway, getting back to the actual code, when we actually load those in there, right, we've got an HHA that tells us where these things are supposed to go. And so what we want to do is say, look, we can build up the path based on that. We just need to append a bunch of things together in order to actually figure out what the actual path is. So, you know, if we wanted to be kind of cheesy about it temporarily, we could just say, look, all right, I don't know how big this file name is going to be, but it's probably not going to be that big. And again, cheesing out for a second, what I need to do is just do an actual format string to put it in here. I guess that's format string like that. Yeah, where I could pass in. Okay, we're gonna put this thing in here. It's gonna be about that big or whatever, right? Or it can't be bigger than that. And we're going to put in a thing that says, look, we know we've got a string that tells us this goes a certain, it goes into a certain base directory, right? So it's going to be source / the HHA name / art / the thing, right? And even this part here is something that we might actually want to have be different because it might be art, it might be music, whatever. So we've got a subdir here. We know it's always art at the moment because we're always pulling in PNGs, but we're going to change that to music or sound based on other things that we might, based on what the block type actually might imply in this particular case. So we sort of have another thing we might want to do there, right? And we'll work on that code a little bit later. And then down here we also have another one that's going to say, look, here's the actual file name that was given to us, right? And so if we want to build up a whole path that tells us the entire thing, we need all of those pieces. So first we need the HHA file, so that's going to be in that fields, right? So we've got that fields HHA. And so that's going to have two things. It's going to have the size and the data, right? And I think, if I'm not mistaken, that's a size T always, and this is a char star always for these. That's just what those have to be to parse them in there. I think we may have added something smarter. I think we added this. I'm just going to say that we did that because we're awesome. I don't know if we did it because we're awesome. Maybe we did it for a different reason, but let's just say that we did. And then we'll let the compiler tell us we didn't, or rather the code tells we didn't later on when we crash, or I should say operating system is the person who's going to tell us we crash. So when we load this stuff out, we're going to have that fields HHA root. That's going to give us where the HHA was. We use that as a determiner here. We got that art part in here, and then we got that file name. That's what we're actually going to load. That's the complete file directory, right? The complete dir name, the complete path. The only thing we don't really know is how big that path is. That's why I say I'm cheesing out here. I don't know if this is big enough. If we had a little bit more of a robust system, we'd just do some concatenations that look at what the size has to be and go from there. We certainly could do something like that. We just didn't this time because, again, we haven't built up enough of a standard library to really make that sort of thing work sweetly. But ignore all that for now. That's not really the thing we're focusing on. What we want to do now is have that path part in there. And I think that's all we really need. So then we'll do our getter create asset source file. We'll do all the merging that way. What we want to do now is say, look, when we look at these file dates, we're going to need to know what the actual file info was. Here's that part. Remember, we did this work. Here's our big chance. This is our big moment in the spotlight. This is where we get to actually call the function we used before, right? That platform call, like we're doing in here, right, where we do get all file types begin, that sort of stuff, we've got to get file info by path. And exactly what we need, right, it's almost like I knew, it was almost like I was clairvoyant. Get file info by path is already in here because we already imported it. Let's see, get file info by, get file by path, right? That's exactly what we need to generate one of these file infos, which is what we need to do our loading and other checking, right? So here's our file info. I'm going to say get info by path. We know we have the file group in here. Hallelujah. We just have it exactly where we need it. Then I just have to pass that path we've generated, which we've got here, and then we're good to go, right? Everything's good. So here we go. Let's see if there's anything else that we needed. I don't think there was. It's just that. That's all there is. So off we go. Right? Everything's great. We get back to file info. Now, if there was no file, right, then we could issue an error. So we probably want to check here because I think it's legal for that thing to return 0 and to say, look, I don't know what you're talking about. I ain't never heard of no file by that name, and so you can't have it. That's totally valid because there might not be a file. We may have just had some kind of an error, when we actually went to type in that HHT file, we made a typo, right? We may already have a typo in there, right? Where it can't find the file. So we need to say like file not found, right? We don't know where that file is. And I could also say looked in here, right? Because we know the full path we looked for. Make sense? So I think that's pretty good. That gives me basically what I want there. I'm going to go ahead and try compiling this, and then we'll start to look for errors, and maybe it's getting time for us to start to try and run this and actually make sense of everything, right? Okay. So coming back here, we didn't really do the append tags thing. Let's actually do it because we might as well get everything working at once. It's not that hard. We've got sort of an import tag array here that we want to actually specify. Again, this should be pretty simple because we already did the work of building tag lists. We have this notion of a tag builder thing. We've got all that working. So we can just go ahead and say, look, have this thing do the tag build like it's doing, right? You can see it here. And the only problem that we're going to run into is in here, you can see it's got this sort of category stuff that we don't need. Doesn't matter because we don't use it for anything, right? It doesn't get used at all anywhere in here. Nobody cares, right? As far as I can tell anyway. So that import grid tag part, yeah, it's a little bit more than what we need. That's okay. We can build it. It doesn't harm us, right? It doesn't hurt us at all. So let's go ahead and do that. We'll say here's our builder. We're going to do begin tags. All we need is that assets array. That's all we actually need there. So we're going to go ahead and pass that in. Here's the assets, like so. We'll begin those tags. During that building, every time we see one of these, here we go. This is us doing that. So let's go ahead and say we got the tag. We don't need this tech token name count blah blah blah. We don't need that, right? That was old news. And here all we need to do is say, look, give us the tag ID from this particular name. We know what it is because in here we've actually done it, right? This token is the identifier that gives us that information. So that's all we really need to get back that tag ID. Assuming we got back a tag ID, then we can do our add. If we didn't, then we need to actually go ahead and, oh, hey, by the way, we did that string format specifier, didn't we? Right? That's the capital S. Pretty sure it's in there. Don't actually know. Let's double check to make sure I'm not making things up. So we look at format string list. Here it is. Let's see if we put in a capital S because we're really, because we're baller. Let's see if we did that. There it is. Bang. Right? Capital S right there. How awesome are we? Very, very, very awesome. So now we can say unrecognized tag name. Surprise, surprise, we actually don't even need the string format specifier though, because we take a token now and we print out our errors, and that's something we can work on a little bit later, but that means that all that stuff would have got handled for us. So we can say in here, look, we don't know that tag name. We have no idea what tag name you're talking about, so please don't ask me to add it as a tag, because I have no idea how that would work. We also now need to do the F32 part of things. When we do this open paren here, you can see us parsing the number. So what we need to do is say, look, by default, the tag value is going to be 1.0. If you don't specify a parenthetical in your tag name, you're going to get a 1.0. That's just a Boolean tag. This is that thing. It's not 0, it's 1. Off you go. In here, what we need to say is, well, if you did have an open paren, then when we get that value back, that's where we're going to set that. So in here, we're going to say, okay, the tag value is going to be the value as an F32 so that we can set it later on. Bingo, we've got it right here. Either it'll be 1 or the parenthetical. Done deal. So now we can specify tags as explicit values using parenthetical form or as a Boolean by just pressing the tag alone, right? Either one will work. It makes it really nice and convenient for us to build those HHTs. So just again, if you don't remember what I'm talking about, in here, we've got this sort of stuff where we say, okay, tags is floor, it's grass, it's whatever. Those are Boolean tags. They just get set to 1 if they're there. They're set to nothing if they're not. We also have the concept that we might want to set a value for it. Look in here, shot index 1, layer index 4. Those are the same tag specifications, same exact thing. It's just now it's got a parenthetical to set what the value is actually going to be because we need to be able to set 1, 2, 3, and so forth, right? Okay, all good. Let's move on back here to tag value. You can see us adding it here. We got the errors here, semicolon, blah, blah, blah. That parsing is just going to work. We already made that stuff happen properly, so I think we're all good there. I don't know that we ever did that. We didn't ever check the parenthetical parsing, so we'll probably have to do that part, but otherwise we're good. When we get to the end of this, we can call end tags. That's the thing that's going to let us get back the information that we actually needed, and so we can create our import tag away result. When we call end tags, we're going to pass it that builder. And if you remember, if I jump back here to the end tags function, oh man, I love this jump thing that we've added. When I jump back here to the end tags function, that's going to give us about import grid tag. Import grid tag is what we need. When I do this thing here, builder, I got to pass the tokenizer, which we have. Asset basic category, which I don't care about at all. So that asset basic category is going to be like asset none or something, right? I don't know what it's going to be, but it's just going to be meaningless because we don't use it. And then we've got this append tags. There are no append tags. So we can actually just pass the result there because we don't need to append anything to it. So this whole thing can just be skipped and will be skipped because it's 0 and 0. So nothing will happen there. So when we come out of here, you can see that the result that we actually receive from this import grid tag, right? This thing right here, import grid tag temp, that's going to come back. We don't actually need that data, but we do need to grab what was in it really quickly. We don't need the struct, I should say, but we do need this part. So the first tag index and the last tag index, that's what we're looking for. So we grab those two out. That gives us the parts we needed to fill out the structure the way we needed to fill it out for our return value. So there it is, done, right? Now our tag parser parses tags, puts them in the format that we needed before, and hands them off as something that can always be copied by anybody else. If I actually go here and look, I just need to do some anding here, and I got to pass the tokenize. I don't know why we're passing errors there. That was just because we modified it. Used to be an out F, so let's fix that, right? So now we've got all that straightened out. What I do need to do now is take a look at anything here that, okay, that's an ampersand L. Take a look at anything here that I didn't actually quite clean up. So parse tags list has got to have those assets, right? Remember when we had that in here, we got to pass the tokenizers and the assets. So let's just add the assets in there. That's how it's gonna, that's where it's gonna put that tag array. For sure. So in here we can look and say, okay, we got append tags, assets undeclared. That's because that comes off the context, right? We don't actually have it as a local variable, so there we go. Chat almost certainly was supposed to be car. I don't know how it got to be chat, so that's a good question. So let's take a look at this here. Size of, oh, that's my habit in my internal code base. I always use capitalized size of. I never did that for Handmade Hero for reasons I don't necessarily know what they are. So let's see here. Get file by path. So I don't know that we ever actually added it to the call table. We probably didn't. Let's go ahead and take a look if that was true. So in here we have like open file and that sort of stuff, where we got the platform file callbacks, right? So we have in here a thing that's like, what was it? Open file, right? There's a callback for open file, right? Right here. We never actually added the call in here to get file of a specific type. So the platform, I'm sorry, for a specific name, get file from path, that has to be in here. So like get file by path has to be an actual call that's in here. And when we actually put in the Win32 side of things, we also have to actually fill it out. So when we say open file in here equals Win32 open file, we need to do the same thing for the platform API. We need to say that that get file by path actually has to be in here as well. So Win32 get file by path has to be in there, right? So once those files are in there, we're good to go. Let's take a look at any other errors we have. In here, again, that's going to be the context assets that we need to put in there. I'm not sure. File group here is going to have to come from the context as well, but that's fine. What else we got? Platform handle, context file group, that's good. Process file info, again, context, this is all context here. Context, right? And what I'd probably like to do here, I'm just looking at it. I don't know about that info struct. That info struct's getting used in a bunch of places. We could just fill it out. Maybe I'll do that now, but I'm going to add a to-do, should this just be the HHT fields, right? So meaning, do we really need this? What was it called? I don't even remember what it was called. It was something like import source info, right? So import source info is just the same thing, and so I kind of don't think it should really be there. It's just a thing that says, hey, like, give me these specific subset of the fields, but there's no harm in just passing the rest of the fields. There's no reason we need to hide that data from the code. It's not like it can do anything horrible with it or something like that. So I don't really know what the point of that would be, right? It just doesn't make any sense. So that all looks pretty good. Now, there's one thing that's kind of janky here, and I'll tell you what it is in a second. And then that's the last thing we probably have to address before we are really just into debugging. I don't know how much time I got left. I think I've got till about 1 o'clock. So I think I have a half hour left, actually, which means we can do some debugging today to get this code into sort of semi-working order, probably not fully working order. So source info here, that was a mistake. I didn't actually mean that. I'm not sure. I think that was just a brain fart. Remember, I'm talking my announcer voice, which takes an incredible amount of energy to program and do the announcer voice at the same time. Because, you know, if we're honest about it, constantly talking is using an entire part of the brain that normally I'm using for programming, so it makes it a lot harder to program when I'm actually doing that voice. I meant to type author, I typed source info, probably because I was talking about source info at the time, and that's just how the brain works. Anyway, moving along, we've got all that stuff now. We have to grab these out of the fields. Oops, that's not correct. And again, even just in the explanation, it was a brain fart. So let's get rid of that. All right. So now moving down to the tokenizer, we have to actually set up that tokenizer. If you remember correctly, we wrote this tokenizer code here. There isn't actually a thing for starting tokenizing other than this one tokenize call. It takes a string as input. That's okay. We actually have what is the equivalent of a string when we open an actual file. But we've got to do that read. So what we need here is we need to parse. We need to pass like a buffer to this thing. So when we do this, tokenize here, when we do this, I can say tokenize equals tokenize something, right? This has to be file contents, basically, right? And then I can pass the address of that, and it can parse the file. So question is, how do I actually read that file data? Well, we already did that, right? We already know what that is. Right in here, we've got this make read stream thing where we can read a content stream, and then parse PNG like takes that content stream, right? So when I do that, make that file buffer, all that sort of stuff, that file buffer that we pass the read stream, that's all I really need. So how do I get that? Well, you can see it happening right here, right? When we do the open file, we do the close file, we do the read, that's all we really need. So in here, when I do I'm gonna skip the file date part, we can still do all of this. Get the file handle, right? I've got the file group, it's right here. So I can just say, there's the file group. We've got the file info. I can say I want to read it. I can create a buffer here that I can pass as file contents. I'll just call it file buffer, might as well, right? We know what the file size is. We can grab a part of data that's big enough for it. We can read that data in, and then we can close it, right? So the only question is, where do we get that data from? Again, we can use a temp arena if we want to here or not. It's really entirely up to us. Since we've got this temp arena here, I'm kind of leaning towards maybe just using one arena that kind of expands and contracts for everything. Seems like it would be the right idea. Why bother having two of them? That just seems easy to me. So I think I might just do it like this, where we just say, okay, yeah. Inside here, when we go to do import our assets, we'll create the temp arena like so, and that will just store all of the stuff that we're working on as we go. When we pass into the parse HHT, I will pass the temp arena in there, so that's how it knows where it's going to get its memory from, right? Very, very simple. And so all the temp arena stuff will just work. Since I want to minimize the amount of memory at any given time, just because I'm a nice guy, I wouldn't have to, because I could just let it stack up and then clear it all at the end. But why not? What I'm going to do is do a begin temporary memory, right? So on that temp arena that we've got, I'll just do a temporary memory. So that in here, when we do that temp marker, something like that, I can do an end temporary memory on the temp marker, right? And that'll just allow us to sort of keep everything in one arena, so we know all of the, everything is just going to get cleaned up by that arena. We don't have to care about it at all, right? It's like free garbage collection. You don't have to pay for it, and it does what you would have done if you had a garbage collector. So it's pretty nice. So in here, excuse me, we just had to clean up the places where we were addressing that temp arena. So every time in here we were passing that temp arena around, all we have to do is just say, look, the temp arena, oops, is already a pointer. So off you go. And I think that's, oops, that was bad. There we go. All we have to do is recompile, and we should be down to our last few things. Parse top level block. I don't know what that takes as a functions call, such as clean up our function calls. Parse level block. Okay, so parse top level block does take a memory arena. Right, I skipped one person in the chain here. I could, I suppose, then put it in the context. Maybe I should do that. This is what I was going to do originally, and then I stopped. I think I'm going to actually do that, so it doesn't actually need to pass it down. In case other people want to use that temp arena, it can just be hanging out in there all the time. That seems like a better idea to me. So in here, I'm just going to say the temp arena is going to come from the context like so. And everyone can use it, and we're good to go. That means out here on the context, I'm going to always pass that around. So the temp arena is in here. Done deal. I think that's everything. Pretty much nothing left to do. This parse HHT doesn't need anything but an ampersand, and we're done. Okay, let's talk about the last thing we didn't do. Where are all of these files going to get written? Once I read in every single PNG, I've got a problem. I'm going to put them somewhere. Where am I going to put them? Well, our old method of putting them somewhere just assumed that it always goes into the same HHA file. But that's not true. It doesn't go into the same HHA file anymore. It's got to go into a specific HHA file, and the HHA file it's got to go into is whichever one is paired with this particular part of the block, right? Because anytime I'm in here, let's say I go to one of those HHT files, anytime I go in here, I say, oh, here's the HHA. That's where it's supposed to go. It doesn't go into local HHA. It goes into intro cutscene.hha, right? So in order to rebuild that file, I have to be able to know this is the HHA that I'm supposed to be targeting, put all the data in there, right? That's got to happen. And so I have to have some way of breaking out of this notion that where I'm putting these things has something to do with this local HHA file. That's gone, right? So this local HHA bit here, this part, that's gone. And the allow editing, that stuff, we just need everything to allow editing at this point, I think, right? So we need to reassess how we're doing that. We need to look at this a little bit differently. And this assets default append HHA index, not a thing anymore, right? Not a thing. So let's go ahead and look at where that's happening. I'm going to go ahead and search for allow editing. What's going on? Where are we using that? Better yet, nuke it. It's gone. Who's using it? Tell me now, Mr. Compiler, tell me what I need to change. So here you can see we were doing an assertion on it to make sure we're going to edit it. Forget that. You can edit everything now. That's just how that goes. The HHTs tell you. Inside allow editing here, we're setting that. That code's going to get nuked. No big deal. You know what? Goodbye. You're out of here, right? Done deal. Let's keep looking. Who else? In if allow editing, this is very inefficient, and we could modify the file to keep separate array of file names, blah, blah, blah. So here we are doing our sort of lookup stuff. So you know what? Again, this is code that could just be run on everybody. So, you know, maybe we just want to do this on if internal, but that's it, because I think that's the only thing, right? So this is just a if handmade internal, you know, off you go. So if you've done your compile in a way that's suggesting you're going to actually be doing edits to the code, that's the only thing that would determine whether you call this, I think, right? That's it. So I think that's what we want to do. If I come down to the import code, I'll put that around it as well. So if handmade internal, but that's the only thing. Otherwise, you're good to go. Make sense? Oops. Okay. So now every HHA is available for editing, and so now we just need to actually figure out for any given asset which one's it going to go into, because it can go into anything, and it's just based on which one you said it was supposed to go into, and that's where we're going to pack it. So let's go ahead and take a look inside the asset code where we have that going. So in here, we can go ahead and take a look at default append HHA index. That's going to get out of here, right? There it goes. So now we just need to see who's actually using that. And remember, it's probably going to be pretty simple. Yeah, you can see it right here. So when we do write image to HHA file, you can see that our situation as it exists is it needs to know which file index it's appending to, right? That's the thing that we actually need. So when we, and in fact, when we actually do that, at this point in the code, we could actually create a new HHA if that HHA didn't exist before, right? We could actually create it. So what we want to do here is have our source info, in effect, tell us that information. Let's go ahead and add that in. So in here, here's our import source info. What I'm going to do is say, when we create that import source info, we also need which file index the HHA is going to be. So we're going to call this like append HHA index, right? We're going to keep this code path the way it was. We're going to do it a little bit higher up. So that asset file index equals 0, asset file index equals default append, right? Now, what I'd like to do here is say, maybe we don't even do the if. We just say we always append to the place that we said we would append. Because the user may want to change the target for this particular PNG, and that's fine, right? So what we're going to do here is say, look, that asset is going to get that from the append HHA index always, okay? Now we'll compile fine. We just won't run fine, or, well, no, we won't, because I used the wrong thing. I meant info, right? I meant that source info, this thing right here. Now I, excuse me. Now I will run compile fine, but I won't run fine. Why won't I run fine? I won't run fine because what's going to happen here is that's always going to be set to 0. We've never initialized it to anything, so it's just going to be garbage, and we're going to not actually append to the file we want to. So what we have to do is go back to where we built that source info, right? And when we pass it down, we've got to actually do the work of finding out what HHA this thing actually goes in, right? We've got to do some kind of a search to figure that out. And so what I can do is I can, again, promote that up to the HHA fields because there's no sense in recreating it every time. So what I can do is, I mean, maybe there is, I don't know, maybe it's too slow. 6.5 dozen, they're hard to say. It doesn't really matter. Point being, at some point, and we can do it like here for now, and we can decide if we want to promote it up later. When we actually create that type right here, what we need to do is say, all right, the append HHA index has to equal to something. So what I need to do is take this HHA fields request here, and I need to get the HHA from that name, right? I need to use that name to go find the HHA, and if I don't already have it, I need to make it, okay? That's important, because so far we haven't done that particular operation other than in the HHA edit. So we also need the ability to sort of create an HHA from whole cloth where none existed prior, okay? And so that's another thing that we're going to have to do. That's okay. Let's get started. How much time do I have? Oh, right. No, like I said before, I got 30 minutes, right? I got 30 minutes. Yeah, yeah. I'm drinking a very strange concoction today. This is what I've been drinking lately for reasons unknown to man. Who knows? Why do I drink almond milk? Don't know. This is 25% Newman's Own lemonade, 75% water solution. So it's like a 1-to-3 ratio, filled with 1/8 of a cup of chia seeds per gallon. And I let them hydrate overnight. That's what I'm drinking. Back to our story. All right, append HHA index needs to get this from somewhere, okay? We need to be able to look up this HHA, and if the HHA doesn't exist already in the asset system, we need to actually create one. So we're going to create a file from whole cloth, which is not something we've really done before. So again, this is something that we need to maybe add a little bit of a support to the file system for, so that we can actually say, hey, when we pass to you, and I don't know if we've done this or not, but inside Win32 Handmade, like if we do open file or something like that, we're going to have to actually tell you stuff like you can, do an open always, right? So you can see in here, if we pass open file right, it will do that, but I don't really necessarily know how we would even get to this Win32 open file because we don't have a file name yet. So when we do get file by path, we may have to augment get file by path to support the case where we actually don't have a file. So in the case where this actually returns nothing, we couldn't find the file, we still need to return a result, right? In that case, with just null everythings or whatever, right? So we're going to have some way of having that happen. So there might be a little bit of an update here. There might be a little tiny bit of a thing that's actually going to happen there that wasn't happening before. So we kind of got to work with that and see how we want to do things here, right? So we've got some work to do there, and we also have some things we might want to change. For example, this stuff here, we may want to change this as well. The wildcarding stuff may want to be changed a little bit. We've got a lot of things we've got to kind of look at. But, you know, as we go, also this can go away. As we're sort of going through it, we can do, you know, updates as necessary. So let's first get this to write to files that actually do exist, and then we'll try to make it write to files that don't exist, because that one's going to be a little harder since we don't have the OS backing yet in place for that, I don't think. So here we go. Inside the asset system, if you remember correctly, each individual source file, sorry, each individual source HHA that we load remembers the fact that it was loaded. You can see it here in asset file. What it doesn't actually remember is the name of that file. And so one of the things you can see here is we got this platform file handle. I don't actually know that the platform file handle tells you anything about the name. In fact, I'm pretty sure that it doesn't tell you anything about the name. So you don't actually have any idea what you're looking at, right? And so what we would need at least here is something that we can use to match, say, the HHA name against this asset file that we've got loaded, so we can search for them by name as necessary. I really would love to know what all this beeping is about. I'm hearing it, but I can't see it. I don't know. Hopefully they're not beeping at me. I don't see how they could, because I'm up. Are you hearing this? I have no idea who's beeping. Why are you beeping? Who are you beeping at? Oh, well, you know, there's like a giant truck or something that's in the alley. I'm guessing that maybe nobody can. I think a giant truck may have blocked the entrance to the building. And someone is like rage horning right now. They're just like slamming on the horn, hoping it will move. Is that what's happening? Oh, yeah. And then they just moved. Yeah. They moved far enough forwards. All right. Nice work, folks. Ah, yes. Living in cities. It's always so good. All right. Anyway. Moving on. So we need some way of actually looking these things up by name. So we at least need to store in here something like a hash value for the file name, so we can see whether or not this is it. So let's at least do that, right? Let's say here this is like the hash of name or something, or hash of file name. Let's put that in there so that when we load these things up, we can actually use that file name to hash it, right? So we can see what the actual file name is. And that's pretty easy to do. So in here we can say when we do our when we actually go through here and load each of these in, right? You can see us doing it here. We go through our files. We can load, we load each of these in. We can check that checksum or something and use that, right? So in order to do that, it's a little bit squinky. Excuse me. When we load each of these HHAs, what you can see that happening here is we don't ever really strip the name down. We just use the name that came back, or rather, we at this point don't really even look at the name that came back. But we have no idea. All we know is that we got back some kind of base name. So what we can do is hash that base name, I guess, and then what we'll do is use the name that we create out of the HHA side of things to go from there. So in here, what I can do is say, look, this file, it's got the asset base, tag base, that sort of stuff. While I'm at it, let's do hash of file name. And so hash of file name will just say the file info base name here. Let's go ahead and take the hash of that, right? Excuse me. But I may want to do it, maybe I want to do this, right? We've got this base name. Maybe what I want to do is create a string here that's going to be, instead of base name, it's going to be like stem or something, right? Without the extension, because I don't really necessarily want the HHA extension in there, because we just refer to things that way, sort of a little bit more generically, perhaps. So maybe I want to be able to get just the stem. And if I want to do that, then what I do is I say hash of file name is actually going to be stem, or in this case I could say hash of stem, right? So we know that it's specifically not including that part. So I can just call hash of shared. Where is that? Hash of string. Okay, string hash of. There it is. So if I just do string hash of stem, then we can get that out. And then here, when I do the stem, I just need to find out where the extension is, right? And so, like, I don't know if we've got anything like that, like find first, or find first slash or anything like that. Extension. Do we have any of this stuff? Remove extension here. Hey, look, there we go. So remove extension will get rid of the period for us. So this is exactly what I wanted, right? So you can remove the path and remove the extension if you want to, which is actually exactly what I wanted. Wow, thank you, past me, for giving future me a library to use. So what I want to do here is I want to remove the path and remove the extension from this base name that I'm getting. I think the base name is just a char star. And so what I want to do, I need a way of wrapping that together. Excuse me. Where is this in? Do we have this in, is this in the HHT? Oh, so I want this code in shared. I want this. Give to Casey immediately. So I need a way to wrap Z. I've got that. So basically this ridiculous line of code here gives me what I want, right? That removes everything from it, and now I just have the stem, and then I can get the hash of it. And now I know for any given file that we've loaded, I can look at the hashes to see if the names match, right? If I want to. So here where I remove the extension, cannot give you one from string to string star. That's totally fine. I guess I should have done this, right? String stem equals wrap Z, and then I can just say, hey, there we go. That's why you probably want to return those rather than take the address of. That's why this is not the best form, because you can't do functional composite. You can't compose them, right? And so it's really better typically to do returns. This should really return the thing, and then you can compose them exactly the way that I did it before. And so, since I moved those to shared, I'm just going to go ahead and do that, right? I'm just going to do it exactly the way that I wanted to. Because why not? So what I want to do here is say, look, let's return these. So here we're going to do it like this. And that, it's still pretty easy to do. So here's just file name init, and then here's file name, right? And then you can just run the exact same code exactly the way you did it before. Right? Easy peasy lemon squeezy. And so all I need to do is change these to that, and off you go. And then the same thing happens with this remove path one. So in here, you pass in the file name, and I just create a temporary, and I return that temporary, and I replace all these so that they're different, right? So they work on a local. Really, really easy, but you can see why it makes sense there, because it's nice to be able to functionally compose these things without having to like line them all up. You can just put them on the same line and then get the thing you actually wanted. I mean, here you can even go even more ridiculous if you just want to be some kind of, crazy superhero. You can just say, look, give me the whole thing. I'm not even gonna ever create a temporary. I just want the hash. So there's this giant hash, right? I mean, why not? Pretty easy. So let's just fix the place in here where that was happening. So in here, this default annotation, all I have to do is, again, just pass this in like this. So the default annotation source file. And you know what? Here you can see it. It's being used exactly the same way. So I can literally just do this and then get rid of this code entirely, right? So again, nice and clean. No reason not to do that. So I think you just do. Going on from there, let me switch it here. So you can see this append HHT index. I have the HHT stem. What I need to do is I need to get the stem. I need to go, excuse me. I need to have something that searches through all the files we have open and finds the one that has this particular stem. So I'm going to make it a function for that because we probably want to do that in multiple places. Potentially, I don't know that we necessarily will, but we might want to. So I'm going to do like a get or create HHT kind of call here, and I'm going to pass the game assets, and I'm going to pass that HHT stem, right? And again, that's just the stem. And maybe I'll say like by stem, right? And so in here, I'll say the getter create HHA by stem. Maybe we'll have the getter create take a true, which means, hey, look, if you can't find it, create it, because we do actually need you to always make one of these. And then I'll put that in here so I can say, okay, here's a way to do that, right? So here's the stem, that's the second parameter. That's actually telling us, okay, look, this is what we actually want the thing to be called. So you gotta find something that matches that stem. And then we're gonna have in here, you know, whether or not you should create if not found, right? Something that says, if you don't find this, I need you to make one. We're not gonna support that just yet, but we will, you know, support it a little bit later on. Okay. So in here we say, here's the assets, here's the stem. What I want to do is loop over all the files that are in the asset system. So let's go take a look at where those are. Inside the asset system, we just have a flat array, I think. Probably, maybe, I'm not really sure. I don't remember exactly how that worked. Yeah, you can see it here. It's file count and files. So all I need to do is start out with the loop. I'm going to go ahead and say which is the file index. So here's the HHA index. I'm going from one to the next to the next. I'm going to look for through each of them to see if I can find that file. If I remember correctly, 0 doesn't actually exist, so I think I can skip 0. But I shouldn't need to because that stem should work one way or the other, right? We should be able to get that hash stem to work one way or the other. So the first thing I want to do is actually create that hash. So here's the stem hash itself. I'm going to go ahead and call that string hash. Right, here's that thing string hash for, or string hash of, rather. I'm going to get that out. Each time I go through one of these, I'm going to pull out that asset file. So here's the file that I'm checking. I'm going to look and see from the array of files, which I'm going through the HHA index here. So from that array of files, I'm going to look at this HHA index. And remember, this thing is going to return me one of those indices, right? So it has to have a result here, and that result can be 0. So I'm going to get, yeah, if that result can be 0 again, right, it means that the HHA index, right, of 0 should be nothing. If I look in here, I want to make sure that that's actually true, that I did leave one space for a file that's like the null file, right? Let me just double check that that's actually the case. So when we get files of type, back in the original situation here where we look at that, get file handle stuff now, not the load bitmap, get files by type. Where is that? No. It's in the startup code. I can't remember what any of it's called at the moment, so I don't actually remember. There it is, right? So this is the code that I'm talking about right here. You can see file index equals 1. I'm enforcing a 0 file beginning. So that means in here I only need to check that first one. So as we go, you know, we're fine. When I look through here, if I find one, I'm going to set the result each of the HHA index and break. So all I need to do is say, like, look, if the file stem hash equals the stem hash that I'm looking for, then we'll consider it a match for now. I could check the string if I want to. I don't really care to do that at the moment, but maybe I'll put to do here, you know, check that stem matches exactly, right? Should I do it? Should I not do it? Should I do it? Should I not do it? You know what? When we think about it, look, here's where we're opening those things in the first place, right? So here's me opening those. I say file index is 1. Here I come through here. I'm doing a bunch of pushes on here anyway. Let's see. File arrows, blah, 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 tag count, file, blah, 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 get all files of type end. And then I come through here and I read the data for the file handle, which is open for that file. You can see right on here I've got an arena for pushing the file count on. So, you know what? Let's just store it. Let's just store it. I mean, so we use a little bit extra in release mode when we shouldn't. I can always if around it if I want to. I could do like an if handmade internal, right, if I want to. So sure. I'm just going to do it. So in here where we actually do the hash of stem, I'm going to do what the stem actually is. So here's the part where I create the stem. In and of itself. So if you take a look at this code right here, I am going to put it in a temporary. Here's my stem. What I want to do is just like push string, right? I want to do a push string here. So put on the arena this thing, right? And give me back a copy of that thing. And then I've got it, right? So when I push that string on, I'm good to go. I have the copy now. So in here I can say if the stem hash is equal, then compare the strings themselves and see. Another thing you can say is maybe we don't even bother looking at the stem hash at all. I don't know. It's a little bit faster. Probably not. The names aren't that long, so who knows? It may be that we don't actually need that stem hash at all. Yeah, probably not. Okay, just get rid of it. There's no sense in having the stem if we're going to store that, the hash rather, so if we're going to store that, we don't really need it. So let's just say here's the file name or the file stem. We're just going to store that. So we don't hash it anymore. We just store the actual stem. So here we just say, look, if strings are equal, and we have the file stem hash, the file stem and the stem that you passed us. If those two things are equal, then it's the file that we're looking for, and we're done, right? So that's all we need to do. We won't have to put that to do in there anymore because we're done, and that's exactly what we wanted. So when we push that on there, we've now got it. We don't need that stem hash at all at any time really anymore. And so now all we have to do is fight the fact that I think, nope, yeah, that's not necessary. That I don't think the push actually works there. I'm not sure about that. What just happened there? I thought we had a push string. What I didn't. Where did I put that? Hold on a second. I put it in the wrong place. Apparently. What just happened? Did you not see me? Okay, I'm an idiot. I obviously deleted the wrong thing or something. Because I'm just dumb. I'm just that dumb, I guess. I don't know. Speaking the announcer voice is hard. Like I said, it just requires way too much talking, and you probably shouldn't be talking that much. But anyway, this was supposed to be a push string, and it was supposed to be stem. And I guess I deleted the wrong one. But it's supposed to look like that, right? That was what was supposed to happen. And apparently I deleted the wrong one. I have no idea why I did that, because I spent the time to write it. You would think I'd have some appreciation for it. But anyway, when it comes back, I believe, again, that push string call, I don't know that we ever wrote one that pushes an actual size string on. Let me take a look and just see what we did there. So you see we got a push string Z and a push string, right? It's really this push string here that we're talking about. What I want to do is put on there a thing that says, okay, you know what? You can also take a regular string as a source, because why not? And then when we do that on here, you can see we don't need to call the string length at all. So in the source, it's actually got the count on there, right? It's got the size of that buffer. And so then that pretty much gives us exactly what we need. So let me just go ahead and finish that up. That looks good. So in here where we do assets file count, I don't know why that got set to game state, just a completion bug there. It's actually game assets, so off we go. And so that's good there. And then here where we do a get or create HHT by stem, that asset is coming from the context, so we need to put that on there, right? And so that's the thing that we needed. Pretty much all of it's written now, except for the part that we need to create one of these HHAs if we don't have one. Right now, I'm not going to do that. So what I'm going to do here is say if result equals 0, then we would need to do it if we're doing create if not found. So if create if not found is set and result equals 0 is set, or rather result is not set, meaning it is equal to 0, then what I need to do is create the actual HHA. So create, you know, a blank HHA here, okay? I don't actually know that we want to do that. We could make it so that for you, what you actually are supposed to do is call HHA edit yourself to create a blank HHA to write into. We could do that. I just don't know whether we want to do that or not. Like, it's hard to say. It's hard to say. I don't know. I really don't. Because what we could say instead, here's what we could say. We could just call this get HHA by stem, remove that, and say they've got to be there at startup, right? You're required to create the missing ones with HHA edit, right? And if we were going to do that, then yeah, you would, because to avoid creating them in case of typos like that. I don't know if we want to do that. It's hard to say. I'll leave it like this for now, and say that we would do that. If we try to do it and can't, we still want to have the support for the failure there in a sense, right, though? So what we probably want to do, too, is when we actually do this info get here, what we want to do is say if, you know, info.append HHA index, do the actual append with the switch, right? But then if we can't, we want to issue an error. We want to issue an error based on the HHA, which basically says, look, couldn't open HHA this for writing. Because that, like, somehow we couldn't get to it, right? For whatever reason. We don't know what the reason is. And then we're done. So I think that's it. So the fields HHA is put in here. So I think that's everything we need. And, you know, now in theory, the game can actually update the HHAs. In theory, right? And I don't know if it will work. Like I said, probably we got tons of bugs in there that we'll have to debug. But the game should still run just fine as it is, right? We should be able to run the game. Oh, that's HHA edit. I don't actually need HHA edit to run. There's no reason for that. This could pop up over here to win 3 to Handmade. So the game should still run just fine, and you know it does. So we don't have any issues with loading the HHAs that we had originally. What we don't have right now is probably any of the editor stuff, right? So if we actually switch into the editor mode, which we will want to do later. I don't know if that'll actually work, but we did all the code we needed to do. So we'll save the debugging for next weekend when we can do that, and then also address things like fonts and sounds or stuff. We can get into finishing up that code. But we did everything we needed to do. Yay for us, just another wire. Let me go ahead and go to a real quick Q&A here for anyone who happens to have any, because I got to go soon after this. So let's just go ahead and do Q&A. Any questions? I've read the sequel says, I actually thought you were just going to vary your pitch a lot more in terms of inflection, not go fast. Everyone on stream was in awe of how fast you're going to be get more done today. No, I don't think so. It's just, in fact, probably less because I have to do so much mental processing to talk. What sort of pre-release checks actions do you do? How do you make your program's industrial strength? For example, do you turn all of your asserts into fatal errors, or asserts into fatal errors? Do you add verbose logging, crash reporters, etc.? So a couple of things about that. First of all, never turn asserts into fatal errors, because the worst that could have happened with the assert was that it would crash if you ignored the assert. So all you're doing by turning assert into a fatal error is guaranteeing that you will crash, right? Which is not a very good idea. So that doesn't seem like a good idea. An assert is a check that you do want on there, but don't make your code crash because maybe the code that came after the assert could have handled it properly. So don't assume it's going to crash. It's not a good idea. But on the more general concept of how do you harden code, there's a couple things that you need to do, right? The first thing you need to do is you need to actually think very carefully about what the critical failure consequences are for your app. In a game, this means losing the player state, right? If a game crashes, that's bad. But if a game crashes and the user can't continue from where they left off, it's, horrible, right? Like if a player's played like 20 hours of your game and then they crash and their saved game's gone, right? That's just horrible. Similarly, if it's like a productivity app or an art app or something like that, if that crashes, that's bad. If it crashes and loses the work, that's horrible, right? So the first step to hardening any app is identifying what cannot fail. And then focus your attention on that first, right? So the first thing you want to do in any of those apps is put in crash protection. And when crashes occur, make sure you protect your save game files, the data from any art that you've created or that sort of stuff. Make sure those can get emergency written to a temp file that you can check as crash prevention. That's the most important thing for hardening. The next step is to try and eliminate crashes that are probably going to happen, right? Eliminate those together. In games, usually that means randomized testing. There is no way to write unit tests for games. It's not possible because games are all about user input and you have no idea what that input's going to be. So what you want to try and do is push as much possible user input through it to find the places that are going to crash, right? If you can isolate parts of the code that you can test with some kind of unit testing or testing in a reasonable amount of time, do it. That certainly helps. But a lot of things there are no ways to write unit tests for in any reasonable amount of time. The amount of time you would spend unit testing it, you would probably are just wasting your time because it would have been better spent on a randomized tester because that's actually going to find things that players are actually going to hit. So randomized testing is a very good way to harden the code. Basically write something that sits on your game and plays it literally 24 hours a day, all day, every day. Run it on as many machines as you have and wait for it to crash. right? When it crashes, look where it crashed in the debugger. This is very, very useful. And it's especially useful because it's relentless. It will never stop testing your game. And that is exactly what you need to find those questions, those crashes, right? Miblo says, I think I spotted a typo in that final print string. %s, not % lowercase s. Which one? You talking about this one? That's a lowercase s, right? That should be a lowercase s, right? All right, last question. How do you keep your mind fresh at your age? You talk really fast. Third from the bottom. Third from the bottom of what? All right, let me just search. That shouldn't be there at all, so that was a good one. That looks right. Although file name is a token, right? Yeah. So that should actually be that. That's fine. And that's fine. Right? Yeah, %s capital means a length-based string. How do you keep your mind fresh at your age? Do you talk really fast? So let me just try and answer that real quickly, and that'll be the last question. So I guess what I would say is I don't know if there's any particular thing that I do that's just the way my brain tends to work, and it likes to be working all the time, so it's not particularly hard to keep it fresh. I don't know. I couldn't tell you. I like to think about things, so I think that creates natural practice for your brain. I don't know. Someone said exercise, it helps your brain a lot. I do exercise regularly. I exercise 5 or 6 times a week. Rock climbing and running. I don't know what else. Yeah, that's about it. All right. Thanks, everyone, for joining me for an episode of Handmade Hero. It's been a pleasure coding with you as always. Let me go ahead and close this out here. Thank you for joining me for this special episode 512. If you want to follow along with the series, you can always pre-order the game on handmadehero.org. It comes with the source code so you can follow along at home. I will be back next week when we will debug our asset building from HHTs, which will be kind of a fun thing to get working, because then we can just ship the game as a completely buildable set after that's done, and we can kind of call the asset system baked at that point, which I'll be pretty happy with, because there's a lot of things we had to figure out there to make it all work right. It does streaming, it does, streaming sound playback and streaming asset playback, and it does on-the-fly updating and all that stuff. So it's pretty darn good for something that we only make an hour at a time or 2 hours at a time. So hope to see you back here for that. Until then, have fun programming, everyone. I'll see you on the internet. Take it easy, everybody.